to Projects. In this video, we are going to explain about the project that is QuickCharNet, an efficient URL classification framework for enhanced search engine optimization. Before getting into the execution, first let us understand what is the project about. In today's digital world, establishing a strong online presence is essential for businesses and also organizations. One of the most effective ways to enhance visibility is through the search engine optimization that we call it as SEO. It is a strategy designed to improve a website's ranking on search engine result pages that we call as SERPs. So it is search engine result pages. This helps to drive traffic to websites by ensuring that content is relevant, trustworthy, and also aligned with the user's intent, which are really key factors in ranking. With billions of searches happening daily, ranking higher on search engines like Google, Bing, and Yahoo can significantly boost traffic and also contribute to business growth. As competition for higher search ranking intensifies, adoptive effective SEO strategies. It requires effective strategies, and that becomes increasingly important. So, as competition for high search rankings intensifies, adopting effective SEO strategies has become significantly important. Search engine uses complex algorithms that assess factors like relevance and also trustworthiness to determine a website's ranking. These algorithms are constantly evolving, making it crucial for businesses to stay up to date with the latest SEO practices. By aligning their strategies with these ever changing algorithms, businesses can improve their chances of ranking higher searches, higher reaching their target audience, and also remaining competitive in the digital landscape. So, when it comes to the SEO, the biggest hurdle is properly classifying URLs, as their processes is crucial for identifying harmful links, detecting spam, and also optimizing rankings. So, traditional methods typically require a lot of manual work, with experts needing to define and select features that might help classifying this URL. This approach can be very time consuming, not to mention resource heavy, and it is harder to scale when you have to deal with larger data sets of URLs. The complexity of URL themselves, with their often messy structures and the demand for real time processing, only add to the challenge. Because of these difficulties, there's growing need for new automated methods to classify URLs more efficiently. By automating by automating the process, we can not only ensure that we are identifying safe and high quality links, but also helps to improve SEO performance by making sure that the links that appear in search results are the best ones. It is all about reducing human effort while making the system more accurate and scalable, which can ultimately lead to better outcomes in terms of site visibility and ranking. So, to overcome all these issues, this project introduces QuickCharNet that aims to tackle the issues of time and memory complexity when it comes to classifying URLs. And it is designed to be more efficient by combining two powerful techniques, that is, character level and token level representation. What this means is that instead of treating URL as just a string, QuickCharNet looks at individual characters first and then groups them into more meaningful tokens. By using methods like, so here, QuickCharNet uses the methods that are mean and max pooling. So this converts these character level details into token level representations, which are more compact yet still rich in information. This helps to make URL classification process faster and more efficient. And QuickCarnet also uses the subword tokenizers, which helps to optimize how it handles the structure of URLs. By breaking down URLs into smaller subword components, the system can better adapt to different types of data and format, making it more versatile. This approach not only enhances the system's ability to prioritize relevant URLs but also improve its ability to detect spam, all while maintaining efficiency in processing. And here we have used URL dataset to train the model. And we have evaluated all of the models built using accuracy, precision, recall, and F1 score. Moving to the extension part, as the extension of the project, we have combined CNN by LSTM and by GRU in as the ensemble model. This combination allows the system to leverage the strengths of each model for better feature extraction. Each model brings a down own perspective and logic to the table, which collectively enhances the accuracy of URL classification and spam detection. By working together, these models can extract more refined and optimized features, ultimately leading to better performance. And to make the system more user-friendly and interactive, a front-end interface is built using Flask framework. This allows users to test the system, provide a platform for evaluation. Additionally, the interface includes user authentication that ensures that only authorized users can access the system. This only adds a layer of security but also enables the hands-on assessment of how well the system performs, making it practical tool for evaluating URL classification, spam detection. Moving on to the implementation, we have followed the steps mentioned in the flow of work. So let us understand what are the steps followed to implement. So first step involves importing necessary Python libraries like Pandas, NumPy, TensorFlow, or PyTorch, and other tools for data handling and machine learning, building the front end. Then comes the next part, that is data exploration. This step focuses on loading the data set, which contains URLs and their corresponding labels, that is spam and ham. It includes understanding the structure of the data, checking for any inconsistencies, and exploring the general distribution of the table. Then comes the data preparation. In this step, URLs are pre-processed to remove unwanted characters such as special symbols or punctuations and converted into character level tokens. This prepares the data for feature extraction and model training. Then comes the embedding generation. Here, BERT-based tokenizer is used to generate token embeddings for cleaned and tokenized URLs. These embeddings capture the semantic meaning of URLs, allowing the model to better understand their structure. Then comes the data splitting part. So the data set is shuffled randomly and split into two parts. One is training and the other one is testing. 80% of the data, 80% of the set is assigned to training set and remaining 20% is for testing purpose. This ensures that model can learn from one set data while being evaluated on the separate unseen set using testing data. Then comes the defining model. So in this step, the model architecture is being defined. This involves selecting a suitable algorithm, that is CNN, BiLSTM, BiGRU, or any other model, and building the layers and components that will process the input data and generate predictions. Then come to model training. Here the training data is fed into the model, which learns from the patterns and features in the data. The model just adjusts internal parameters to minimize errors and improve the accuracy over time. Then comes the performance evaluation. After training, the model performance is evaluated using metrics called accuracy, precision, recall, and F1 score. These metrics helps to understand how well the model is classifying URLs into spam or ham categories. Then comes comparing the model performances. Different models are compared based on the evaluation metrics to identify which one performs the best. This helps in choosing the most efficient model for the task. Coming to the part of front end, the front end interface is built using Flask framework, allowing users to interact with the system. This includes setting up a registration and login system using an SQLite database to store user information. Coming to user gives input, the user interacts with the system by providing input, typically a URL, through the front end interface. This input will be processed for prediction. Then comes given input is pre-processed for prediction. So the provided input is pre-processed like cleaning, tokenizing to make it compatible with the model's input format for prediction. Then training the model. So train model is used for prediction. The pre-processed input is passed to the train model, which generates the prediction, that is spam or ham, based on patterns it learned during training. Then finally, prediction, that is spam or ham, is displayed to the user on the front-end interface, providing clear result of the URL classification. So this is how we have implemented the project. Moving on to the algorithms used. These are the algorithms used. This is the proposed model, and this is the extension ensemble model. Coming to the requirements, to implement this project, we need basic requirements, which are nothing but hardware and software. Coming to hardware, we need operating system of Windows, processor of i5, RAM of 8 GB and above, hard disk of 25 GB and above. Coming to software, we need application of Python, front-end framework Flask, back-end framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now we need to execute the project. To execute, we need to open the code folder which contains source code files. So let us open the code folder of the project. So these are the source code files in the code folder of the project. Let us understand each of them, how will they be used in this project. So in the first folder, that is dataset folder, we have dataset that is used. So this is the URL data that we have used it for training the model. So these are the different URLs. And here in the category column, we have target class, that is spam or ham. We have two classes that we will be predicting in this project. So all those URLs are trained so that we will be able to predict whether the URL is spam or ham in the front end. Now let's close this. And here in this test data file, we have test cases that we will be using in the front end to detect whether the particular URL is spam or ham. So total here we have 10 test cases that we will be predicting in the front end. Let's close this and get back. In this model folder, we have .h5 files, pickle files, and numpy files in which we have the algorithm information stored, and that will be loaded into the project code during runtime of the application. Then comes the next folder, that is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here we have is a templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be represented in HTML templates. Here we have notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. To execute, copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open command prompt. Give the command cd, give the space, paste the copied path, and now click on enter. Here, if you observe, current directory is changed to the code folder's path. Now we are supposed to compile app.py file, so give the command python space app.py and now click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. This 5000 is the port. Now we need to copy this local link which is provided by the Flask framework. So copy the local link and paste it into any web browser. So paste the link here, click on enter. This is the web page of the project which is displayed in the browser, and this is developed using Flask framework. Now we need to sign up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in now. Give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see a choose file button, right? We need to click on that for uploading the test case file. Click on that. So we are supposed to upload this file. Click on open. It has been loaded. Now click on upload. So this given input, it will be pre-processed at the backend and then train model will be giving us a prediction. So this is the first URL that we have given and here it has predicted as it is a spam URL. So it is a spam URL. And the second URL which we have given, it has been predicted as ham URL, which means it is non-spam. It is a safe URL. And the next one we have is the spam URL predicted. So this is the URL that we have given and here we got the prediction as spam. Similarly, for this URL, it has predicted as ham. Accordingly, for all the other URLs that we have provided, it has predicted as, if it is spam, it has predicted as spam. If it is ham, it is predicted as ham. Ham is nothing but it is non-spam. Now let's check with the graphs. Click on graph. So here, first we have is a confusion matrix of the extension model, that is QuickCharNet CNN with BERT with ByLSTM and ByGRU. So this is the confusion matrix. Here on x-axis we have predicted class and on y-axis we have true class. And this is the accuracy score comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms that are trained in this project. And this is the precision score, this is recall score, and this is FN score. Here, if you observe, the extension model has highest performance metrics among all the algorithms that are trained. Now click on sign out. In this switches, by providing the input as URL, if the URL is spam, it will predict it as spam. If it is not spam, that means ham, it will predict it as ham. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Project's YouTube channel and subscribe.